Welcome all, I am Parthiban Parmeshwari. In this presentation, going to present about steam turbines of thermal engineering. First of all, I will give introduction about steam turbine. Prime movers in which the potential energy of the steam is transformed into kinetic energy and later in turn is transformed into the mechanical energy of rotation of the turbine shaft. Turbine shaft directly or with the help of a reduction gearing is connected with the driven mechanism. Based on the type of driven mechanism, it is used for power generation and transport. The advantages of steam turbines over the steam engine. Thermal efficiency of a steam turbine is higher than that of a steam engine. Power generation in a steam turbine is uniform, hence flywheel is not required. Higher and greater range of speeds is possible than in case of a steam engine. Steam turbines are very much suitable in large thermal stations where we need higher outputs. With the absence of reciprocating parts, the balancing problem is minimized. No internal lubrication is required. No rubbing parts in steam turbine. In a steam turbine, there is no loss due to initial condensation of steam. Steam turbine can utilize high vacuum very advantageously. Considerable overload can be carried at the expense of slight reduction in overall efficiency. Here and here the steam turbine classification according to the action of steam. First one impulse, second one reaction, third one combination of impulse and reaction. In the figure 26.1 shown that impulse turbine, the left hand side, where we can see the fixed nozzle which is fixed at, against the rotor blade. Here the fixed nozzle supplied that water jet on the rotor blade. The jet going to hit on the rotor blade due to the torque will generate the rotary motion of the rotating shaft. Finally able to run the generator steam turbine so that we can able to generate the power through the impulse turbine. The reaction turbine is also in that similar manner of the impulse turbine. The difference is that the nozzle directly fixed on the rotor of the shaft instead of providing that rotor blade. This is the basic difference, and both end of the shaft hanging by rotary bearing. The steam supplied through the soft center portion. There will be a hollow and a circular section available to enter the steam to inject the steam through the nozzle. Other classifications also made according to a number of pressure stages, single stage turbine and multi-stage impulsive and reaction turbines. According to the direction of steam flow, we can classify into axial turbine and radial turbine. According to the number of cylinders, single, double, 3 and 4 cylinder turbines. According to the methods of governing, the turbines with throttle governing, turbine with nozzle governing, turbines with bypass governing. This kind of governing going to explain that next part. And then according to the heat drop process, condensation turbines with generator, condensing turbine with 1 or 2 intermediate stage extraction, back pressure turbines, topping turbines, back pressure turbine with steam extraction from intermediate stages at specific pressure, low pressure turbines and mixed pressure turbines. And according to steam condition at inlet to turbine, low pressure turbines, medium pressure turbines, high pressure turbines, turbines of very high pressure, turbines of supercritical pressure, which means there we can where the steam pressure will be more higher at the supercritical pressure compared with low pressure turbine. According to their usage in industries, stationary turbines with constant speed of rotation, stationary steam turbines with variable speed, non-stationary turbines with variable speed. And also the difference between the stationary turbine and the stationary steam turbine, where the constant speed is providing to achieve the stationary turbine, but in the second case the stationary steam turbine with variable speed means where they are providing that different speed according to the steam pressure and velocity condition, so that they can able to run the steam turbine through this category, stationary steam turbine with a variable speed, and non-stationary turbine with variable speed, which means that turbine can able to move from here and there with a different speed. So according to the industrial purpose, we can use that different kind of stationary turbines. And within this I will conclude this presentation. This continuation will be come that part 2. Thanks.